can see there. We're glad to have you here today for Water Talk. Today we have Mr. Bob Henszey, who is a research associate with the Wyoming Water Research Center and is currently investigating the hydrology of wet meadows along the North Platte River in Central Nebraska, which of course is the title of his talk. He is also pursuing a PhD through the Department of Range Management. He received a BS degree in wildlife management from Humboldt State University in 1980 and a Master of Science degree in range management / water resources from the University of Wyoming in 1988. He has worked 6 seasons as a technician in California and Wyoming for the U.S. Fish and Wildlife Service and also for the Bureau of Land Management. And with that, I'll turn the time over to you, Bob, and we'll let you go. I'm interested to see what he's doing. I haven't seen this for a while.
Go ahead and go right into the slides, I guess. Oops, we're already not going anywhere. Yeah, it doesn't go forward or reverse. I hope you edit this thing. You don't edit it?
I get to see the whole...
There we go. Am I in control of the lights here or somebody else's? Okay. Oops, we got ahead of ourselves somehow there. Okay, many of you have probably heard about the importance of the wet meadows in the Central Platte in Nebraska for migratory wildlife, in particular sandhill cranes and whooping cranes. But not only are there migratory wildlife there, but there's also resident wildlife too. And the Platte River, this is the Platte River, not the North Platte River, is much different than the North Platte River that we have in Wyoming. It's a wide braided channel with a sandy bottom. And from one edge of one channel to the far edge of another channel could be as much as a mile. The river can be as much as a mile wide with islands in between. Even though the importance to wildlife has been fairly well recognized, the hydrology that maintains these meadows and supplies water during the migratory season is fairly poorly understood. There's some opinion that the water may come from the river, or it may be totally dependent upon precipitation events, or it might be a combination of both of those. So in order to quantify the hydrology of the wet meadows along the Central Platte, the U.S. Fish and Wildlife Service contacted us in 1984 and asked us to try to quantify these different factors. And the U.S. Bureau of Reclamation is currently funding us for this fiscal year, and we're conducting the study in cooperation with the Platte River Whooping Crane Habitat Maintenance Trust and the National Audubon Society. The objective of our study is to examine the seasonal relationship between wet meadow groundwater elevations and river stage, precipitation events, evapotranspiration, and local irrigation. So basically we're trying to decide what effects these factors have on the groundwater underneath the meadows in the Platte River. The principal investigators on this study are Tom Wishy from the Department of Range Management and the Wyoming Water Research Center, Quentin Skinner from the Department of Range Management, and myself from the Wyoming Water Research Center. I'd also like to take this time to acknowledge Larry Dolan, who was the first project scientist on this study, and he's the one that set up most of the study design that I'm going to present today. Over the years, Tom Wishy and Quentin Skinner have been putting together study research watersheds ranging from alpine to cold desert. And with the addition of this study area, we now go from alpine all the way out into the Great Plains. So we now have a broad spectrum of study areas that we can check or investigate different relationships relating to riparian zones and aquatic habitat. 2 of these areas, go ahead, get the pointer here, are within the Platte River drainage proper. The Snowy Range is a tributary to the North Platte River, and the Pole Mountain Research Watershed is a tributary to the South Platte River. Our methods: study areas located in south central Nebraska after the confluence of the North Platte River that comes from Wyoming and the South Platte River that comes from Colorado. The actual study areas that we're in, there's 3 study sites that we're looking at. 2 of those study sites are located on large islands within the Platte River proper, and they're Crane Meadows and Rose Sanctuary. The Elm Creek study site is located along the south bank. Okay, we selected these study sites in cooperation with the U.S. Fish and Wildlife Service, the Platte River Whooping Crane Habitat Maintenance Trust, the U.S. Bureau of Reclamation, and the National Audubon Society. These study sites were selected to represent a variety of topographic patterns as well as drainage patterns and plant community types. At each of the study sites, there was either a previously existing cross-valley transect across the Platte River that was installed by the Bureau of Reclamation, or in the case of the Elm Creek study site, the Bureau of Reclamation installed an additional cross-valley transect for us. That'll give us, we'll go backwards. What that provides is a two-dimensional representation of the valley with the groundwater levels in relationship to the surface profile. In order to get a three-dimensional representation of the groundwater at these study sites, we established a grid of groundwater wells. And this grid is measured or sampled at least on a monthly basis with supplemental measurements during critical time periods, which occur during when the cranes are there, which is right now, and during the summertime when irrigation is happening. In addition to these point measurements that we're taking, we also have continuous groundwater stage recorders out there so that we can monitor on a continuous basis the response of the groundwater to different events. We also have a continuous river stage recorder so that we can continuously monitor the effects of river stage on the groundwater. And we also have staff gauges located at the corners of our study area so that we can monitor the slope of the river, or in this case, a drainage ditch on one of the study areas. Okay, each site has a weather station that consists of a minimum of a weighing bucket precipitation gauge and a thermograph for measuring air temperature as well as soil temperature at 4 and 40 inches. At the Crane Meadows study site, we also have an expanded weather station which has a totalizing anemometer for measuring the amount of wind travel over the month, as well as an instrument for measuring solar radiation. And then inside the shelter, we have instruments for measuring barometric pressure and relative humidity. These will help us quantify the evapotranspiration rates out on the meadows. Okay, we also contacted all the irrigators adjacent to our study areas so we could determine the effects of groundwater pumping on the groundwater underneath our study sites. Our preliminary results, and I'd like to stress that these are preliminary. I'm still in the process of madly working through our data, trying to fill in missing gaps and keep track of all of our different elevations for the well casings, which is a major accounting headache I've discovered. Okay, the Elm Creek study site has this grid that I've been talking about. This particular study site has a grid of 9 wells here, plus an additional 2 wells that are just upstream of a drain that does not show here. This drain runs from east to west, and it intercepts groundwater flowing towards the river, which is up here. In this case, the Platte River is a braided channel here, and we're looking at the extreme southern end of one of the channels. In this particular channel, there's a lot more islands that are in here that would confuse this particular graph. But anyways, this particular channel here, I think, is primarily fed by groundwater, except for during high river stages. In addition to this grid, we have our 3 continuous recorders for measuring groundwater on a diagonal like this. Then our continuous river stage recorder right here. Then we have staff gauges located that aren't represented on this particular figure. Staff gauges located on all 4 corners. There's one on the drain here and one over here also. There's also 2 additional groundwater wells that are over on a slightly different drainage pattern that we're looking at also. And then the Cross Valley transect, you can't really see it here, but this is one of the wells here. They run down this way, and then they start on the other side of the river and go north. And when you look at that 2-dimensional, whoops, we're not there yet. This is a photograph of the drain here showing what it does is it intercepts the groundwater moving across the land here into the drain and then shoots it off towards the river somewhere downstream. And our study area is located over in this area here. Okay, here's the 2-dimensional representation of the groundwater relationships. Here's The white line is a surface profile with the study area here where all these little squiggles are. I smoothed out the surface profile outside of the study area. Then the Platte River from one extreme bank to the other extreme bank. There's a lot of islands in here that I didn't bother to represent. And then we have 4 different stages of the groundwater there, ranging from January 9th, or the first part of the year, March 15th, which is the peak of the crane season more or less, August 21st, which is during probably the peak of the irrigation season, and then later on in the fall. And what I'd like you to get off of this is that except for during the irrigation, the groundwater levels are pretty darn close to the same thing, except for when they're irrigating, and they do tend to depress that water just a little bit, but this goes from 2280 to 2290, so you're not talking more than about 5 feet at the most way off of here. Next slide will be a zeroing in of that particular area right there. Here we are with the south channel or south bank right here. Here's that drain I was talking about. It does tend to intercept the groundwater coming in and then shun it downstream. But as you can see, it probably would not have made much of a difference when you get further out here into the study area, only right here in this little area here. Again, most of the year the water table is pretty close to the same positions except for during that irrigation time when it does come down. But it's still not coming down all that much. Another thing I noticed that's kind of interesting is in this particular case it does look like the groundwater just flows in a fairly straight line between this drain and here. Does not appear to be much of a flow, or it does not appear to be flowing this direction or that particular direction, at least from this slide. When I get into our data analysis a little bit more, I'll probably be able to quantify that a little better. Okay, the Roe Sanctuary, which is operated by the National Audubon Society, that's located on a large island between Platte River channels here. We have a small grid set up on one part of the island. We don't have the whole island in this particular case. This is a grid of 12 wells, again with a diagonal of continuous recorders here for continuously recording the groundwater stage, continuous recorder here for measuring the river stage, as well as a staff gauge over in this corner here. And then here's the Cross Valley transect that was installed by the Bureau of Reclamation. And if you notice, this Cross Valley transect is actually kind of downstream. If you really install this properly, it should be pointed about like that. And the reason they did that, it was just simpler to follow section lines along county roads and things. So when you see this next slide here with a 2-dimensional representation, this channel actually comes out lower just because the transect actually goes lower downstream. So what you have to look at is kind of the relationship between the groundwater levels and the surface profile to get an idea of what is happening there. Again, here's the study area where all these squiggles are. You can see there's a lot of relief going on in a very short period, or very short distances here. Again, I don't have the November water level here, but I do have the first 3 times, same time periods as the previous graph, and you can see they're all still fairly close together, except for during the irrigation season when it does tend to be a little bit lower. Here's a close-up of the area again, with the actual study area here and the island all the way across here. And then what you can see is there really is very little change in the groundwater level here. We're talking 2 feet from here to here. That appears to only be about a foot of difference from March 15th to August 1st. And that changes depending on the river stage. This just happens to be a couple time periods when these were taken. If we had one of these right after a precipitation event, which I'll show on the Crane Meadow study site, you can see some different fluctuations that are a little more responsive than this. Getting into what the precipitation actually does, this graph is kind of cluttered, but it's the best I have for right now. What we have here is this bottom line is the actual river stage. It kind of intertwines with this one river, or with one groundwater well. But these other 3 are the groundwater, and this is on a continuous basis, so we are seeing how the groundwater responds. What I want you to get off of this is after a precip event like this, you see the groundwater jump up to a higher elevation almost instantly. And from what I could see this week when I was out measuring groundwater, you can actually measure it coming up if you want to take samples every 5 minutes. But what happens is the groundwater comes up in a big hurry and then stays up there for maybe 2 or 3 days and then begins to decline and comes back pretty much to the same level that it was prior to the precipitation event. And another way to represent our continuous recorder information is on what we call a depth duration or depth to groundwater duration curve, which is very similar to a flow duration curve, which works on a probability basis, which says 100% of the time, in this particular case, the groundwater level in these 3 wells was at least 3 feet or higher, or shallower, I guess I should say, from the surface. And if you want to look at 50% of the time, in this particular case, the groundwater level was at least 1.8 feet or shallower to the surface. And this is probably the best way to represent groundwater elevations for plants. I think you can get all kinds of good information out of this. So you can see over here, on maybe 1% of the time, the actual groundwater in these particular 2 wells was actually above the surface. Or you could say 60% of the time the groundwater was in this range here, 1 to 2 feet for most, 1 to 2.5 feet for most of the wells. Also put the river stage along here too, so that you can see how that looks compared to those curves, and they're fairly have about the same shape. The only thing you don't really know for sure unless you get into the data is whether this 5% of the time is the same 5% of the time that this is happening. And those are the kind of things that we'll get into when we start analyzing our data a little bit closer. Okay, the Crane Meadow study area. This is operated by the Platte River Trust. This time we have the whole island to work with. We have a grid of 15 wells in this case, with a diagonal again of our continuous recorders going across like this. And then our river stage recorder is over here on the southwest corner. We have staff gauges located on the other 4 corners so that we can measure the slope of the water going down these channels. And then the transect again is like this, and in the same case as the row sanctuary, it really should be tilted like this. But it was a lot more convenient for the Bureau to install them running along section lines. Okay, the 2-dimensional representation again of the Crane Meadows. This time I have 3 dates that are a little bit closer together, showing what the kind of changes you can have. That, looking at the green and the orange, is pretty much more or less the base level here. This yellow line was measured right after a large precipitation event last June. And you can see that the water table did jump right up. And when we zero in this area here, which is the actual Crane Meadow study area, you can see that that groundwater does appear to actually be intercepting the bottom of some of the swales over there. And if you can believe these particular data here, it does look like water is coming from the channels into the supplying water to the groundwater. You can see it dropping down here, and I think you can see a little bit over here on the green line. Except for when you're getting close to the base flows in the river, then they appear to be about one and the same. Now this is a 2-dimensional representation. And when we're using our grids, what I'd like to do is make it's not really 3-dimensional, but it's using 3-dimensional information to develop these contours. And this is the kind of information we'd like to develop for all 3 of our sites, showing how the water tables, or the contour levels of the water tables, or the water table out there. And I haven't had much chance to deal with these, but I'm just about ready to get into these and see what kind of information we can draw out of that. So finally, in conclusion, we are getting a better feel for what the groundwater hydrology is out there, and the effects of precipitation and river stage and the irrigation. The evapotranspiration is the one thing that we need to get into, and we'll get into that in the next few weeks and find out what kind of effects that has. So if there are any questions, I'll entertain your questions.
You have no soil monitoring?
There's been a little bit of that, but we've been dealing primarily with water table information just because it's a lot easier to get. Yes, Dick?
Bob, when you compare the response of groundwater to river stage between the different sites, do you see any differences? And if so, what do you ascribe those to? Or have you done that? Or
Well, I haven't done it much. I'm trying to think of what I can see from what I felt. And
let me suggest one possibility. I know one factor that affects groundwater response to changes in river stage is the shape of the channel, the cross-sectional shape. And basically, if it's a wide, shallow channel where the flow is spread out more along the wetter perimeter, there's more seepage loss as opposed to a narrow and deep channel. And do you have a feel for any if those changes, those differences might exist and have any influence?
Well, it's all pretty much a wide channel everywhere. So one thing I didn't point out, and I got in trouble with the Bureau of Reclamation was that a lot of times you hear above Kearney, which is the Elm Creek site, that's a gaining stream. And if you looked at my slide, you can kind of see that does appear to have water coming in from the sides, and the other two sites are downstream, which they call a losing stream, and it does appear that water is going out. And one of the things we've been toying around with is on the Crane Meadow site, you can actually see kind of a dip in the island of the groundwater between channels. And is that due to evapotranspiration, or is it due to just a loss to the groundwater table out there in the whole study area? Are there any more questions? Yes.
Expanding on that point was made about gaining larger balance beyond just your line size. Where's all the water coming from? Where's it going from?
We haven't. I think that's the Bureau of Reclamation has a lot more of these transects out there, and I think that's the primary purpose of their transects is to try to look at, long distance. We're looking right at on the Platte River, basically, the groundwater relationships, and they're trying to go out from the banks and try to determine what's going on out there. And I haven't heard any of them talk about their data yet, so I'm not sure where they're at with that. Yes?
Do you have any lysimeters?
No, we've talked about putting one out there. It's not in our proposal, although it's something. Well, right now we're quantifying the actual hydrology. Ideally, the next step would be to take that information and say, right now we're saying, here's what's going on now. Now, what kind of effect does that have on the plants? And that's where I think the lysimeters would come in. Larry, did you have a question?
Yeah, one of the main focuses for this study is for the cranes.
Well, the cranes,
Habitat.
yeah, during this time of year, the cranes apparently go out into the meadows and they hunt up little invertebrates and things. And in order for them to be out there, I guess they need standing water out in the meadows. And there's been some discussion as to where that standing water is coming from. Is it coming from precipitation events that are held there because of the infiltration rate is real poor, or maybe there's ice underneath of there that's locking the water in place? Or is it actually coming in from the groundwater on the side? And it's probably a combination of both of those.
So one of the things would be Nebraska's asking for additional water releases from water. Or not?
They are. I've tried to stay out of the political stuff as much as possible.
So staying out of political stuff, if they send more water down, the way you showed your groundwater flows, do you think you'd have more water percolating up in the riparian habitat for the cranes and the rivers?
From what I've seen, what it appears is that if you raise the river stage, and I'm not talking about flows, that's a completely different thing. If you raise the river stage, you do raise the average groundwater across the site. When you get these precip events, that kicks it up and brings it up to the surface for whatever period of time it's going to be. And usually it's probably a week or less, and then it falls back down again. I don't think they probably want to try to maintain the river flows high enough to get that flooding all the time. I have a feeling that'd be phenomenal amounts of flow. Are there any more questions? Well, that's short but sweet. Ask me back when we have some more information to talk about. So,
Okay, I'd like to thank Bob. Want to remind you that there is no water talk next week, but there will be one on the 23rd. So we'd like to invite you all back in. Thanks again, Bob.
okay.